So tonight, as you can see, I'm at the JV football game, very first one, season opener of the night. We were winning 30-0 against Venice. You'll be happy to know we ended up winning that game 37-7 against Venice. Yeah. So that's always a good feeling. Okay, so now we can start talking about parent functions. Now that's out of my system. There are for this section, there are four major functions that you need to know. One is the constant function. So if I had something like y equals 3, then that means I would go up to 3 on the y-axis, and I would draw in a line, and that's a constant. That means everywhere on the x-axis, the answer is always 3. So anything that you choose, the answer is 3. Okay, so that's why it's a constant. All right, so another example of that could be something like y equals -2, where I'd go down to -2. Oh, well, I missed it there. And that would be that line. Okay, let's see. So the next one is the linear function, and I think you're all familiar with this, but this is like mx plus b. But the original of that is y equals x. When we take this m and this b, what we're doing is we're transforming the y equals x graph in some way. So the b changes it and the m changes it in some fashion. Okay, let's see. And the absolute value function, I think you guys are okay with that one by now. We've talked about that a lot in class, but we're going to be transforming that and basically shifting it up, down, left, right, flipping it, and all those things. So that's where we're leading to. Same thing with the quadratic. So you know that anything that has an x squared in it is a parabola. All right, so you just want to make sure you have all these things checked off for yourself. Hope you did well on the previous two questions. What you see here is an example of what would be asked in your workbook. So the first thing asked me to do is to identify the function family. So that means which type of graph is this. So hopefully you can see just by the look of it that it's an absolute value. So your first answer is it's an absolute value graph. That is the parent function. Okay, so now what we're going to do is compare that graph to the original. So the original absolute value graph would be at, if we were going to plot that one, let's see, if you're not sure what it is, you can always plug in an f of x chart. That's why we learned it so well. So you can plug in 0 into absolute value of x, you get out 0. Okay, so I know that point, that makes sense. And then if we plug in 1, we get out 1. If we plug in -1, we still get out 1. So -1, 1. And then so obviously what's happening, I think you can see here, you basically have slope -1 on this side and +1 on this side. So as you plug in 2, you get out 2, plug in 3, you get out 3, plug in -2, 2, -3, 3. Okay, so what we want is this original function. Let's see how well I can do this. This should be interesting. Okay, that's not too bad. So what we can see from this function here that's been graphed is it's changed. The original is in my blue that I plotted, and we want to see how that changed going to this other blue function that was already on the paper. So it looks like from the vertex it moved up 1. So, that's interesting. Let's write that down. Up 1. Okay, and then the 2 is going to make this actually, it looks like it shrinks a little bit. Interesting. So we're going to be developing some of that stuff in class tomorrow. Hopefully Zach and Ginger will stay quiet long enough to finish this recording on this last page. Okay, so here's a couple more functions. It wants us to graph x minus 4. So we're still going to do that for now in this section at least. In the next section we can stop with the x and f of x chart unless we need it. But let's plug in 0. We're going to get out 0 minus 4, which is -4. Okay, then we're going to plug in 1, and we'll get out 1 minus 4, which is -3. Okay, and then let's go ahead and do -1, just to see what that looks like. So -1 would be -1 minus 4, which is -5. -1, -5. Now, if you know anything about lines, you kind of could probably have done this already. Go down to -4, and then it has a slope of 1. So we sort of had that already. So let's just draw that sucker in there. Okay, so that is this part. It says graph that function, but then it also says graph it with its parent function. Okay, so the parent function in this case is going to be the f of x equals x, which is the linear function. Okay, so that means if you don't know how to graph it, you can go back a couple pages, or let's just try some points. When I plug in 0, I get out 0. I don't even need an f of x chart for this one. Plug in 1, I get out 1. When I plug in 2, I get out 2. When I plug in, let's see, -1, I get out -1. -2, -2. So that one's pretty self-explanatory. All right, so what happened to this graph then? It looks like, and if I were on graph paper, I could see this a little bit better, but basically what happened was this moved down 1, 2, 3, 4 places. So when it says describe the transformation, we would say down 4.
What you doing, baby?
Sorry about that. In the last slide, Jeff didn't know I was recording, so you heard him at the end walk in and ask me what I was doing. But so now we're back. And this, I just wanted to show you an example of what the textbook solution looked like. So this would be the question here in black. And so what, if you were looking at the back of your book or looking up solutions, this is how it would look. So it'd have f of x is always going to be your original function. So like the parent, I mean. So that would be this one, always drawn first. And then the one that they're asking you about is usually g of x or h of x. And so that one is the one that you see graphed. And then your job is to figure out how it's changed. So this one, we see it's a horizontal translation 1 unit lift. So that's going to be important. In the next section, you're going to learn how to quickly get those transformations.